Find the exact value of sine u plus v, or alpha plus beta, given the sine of u is equal to 3/4, given the cosine of v is equal to negative 5/13, and they're both quadrant 2 angles. So something to keep in mind, u and v are just angles, like theta. Right, so we're adding two angles together. They're both quadrant 2 angles. We're adding those together. And we don't know the actual angle. So instead of knowing that it's 75 degrees, we know the ratios. The sine of that angle is 3/4. And for v, we know the cosine is equal to negative 5/13. So you can give yourself a visual. Draw your quadrant triangles. So for u, sine of u is equal to 3/4. So we're going to draw an angle in quadrant 2. Where the opposite over the hypotenuse is equal to 3/4. So you have to be careful, because when you see the right triangle in the 3/4, you want to say 3/4/5, but that's not the case here, because the hypotenuse is 4. So to find the missing value, we're going to do 3 squared plus that base squared equals 4 squared. And so we'll have 9 plus something equals 16. 16 minus 9 is 7, so this will be square root of 7. Just to double check that, 3 squared is 9, root 7 squared is 7, 9 plus 7 is 16, that equals 4 squared. So I have my triangle, and just to make sure we're clear what's going on here, I'm going to use my green pen. This is angle U. To find angle V, I'm going to take quadrant 2 and draw a triangle whose cosine is negative 5/13. So negative 5 is going to be my x, 13 is going to be my hypotenuse, and this is a Pythagorean triple, 5, 12, 13, so my opposite side is 12. And again, with my green pen, this angle is V. So what this problem is really saying is that if you took angle U and you took angle V, and you added them together, what would you get? So angle U starts here, and then V is also a little bit greater than 90 degrees. So if I had to start here, and we're trying to evaluate the sine of that. So it looks like it's going to be inside quadrant 3. It could be inside quadrant 4, but all I really know at this point is that because it's in quadrant 3 or 4, the sine of that angle is going to be negative. Now the reason that I finished the triangles and found the third side is because in order to do sine of u plus v, I need sine of u and sine of v, and I need cosine of u and cosine of v, because I'm going to have sine of u times cosine of v plus sine of v times cosine of u. So using a blue triangle, the sine of u is equal to 3/4. Using the red triangle, the cosine of v is negative 5/13. Then staying with the red triangle, the sine of v is 12/13. Remember that the sine of the red triangle, like even though v is that green angle to the right, if I call inside here like v prime as a reference angle, the trig values for all the reference angles are the same as they would be for quadrant 1 angles. So we can do this way. So cosine of v prime, I could say, or sine of v, sorry, sine of v prime, is opposite over hypotenuse 12/13. And then back to the blue triangle for cosine u. And cosine on that triangle is going to be root 7/4. So my denominator is 4 times 13, which is 52. Think of cards, 52 cards in a deck. And then on top I have 3 times negative 5 is negative 15. And then I have 12 root 7. So I could use my calculator to double check that. I'd have to find out what angle U and angle V are in order to do that. But that's the process you're going to go through. Draw your triangles in the quadrant they're supposed to be. They're both quadrant 2. Find the missing parts because you're evaluating sine and cosine, and then just substitute into your expression.